Hey, hello guys. Just 1 minute and we'll start. Okay, our first question. What is hypothesis testing? Hypothesis testing. Yes, anyone? What is hypothesis testing? Yes, guys. Anyone? Please reply in the chat. Good afternoon, Ipsita. What is hypothesis testing? Okay. Hypothesis testing is while performing an experiment. Hypothesis is to used to analyze the various factors that are assumed to be an impact on the outcome of experiment. An hypothesis is some kind of assumption and hypothesis testing is used to determine whether the state hypothesis is true or not. Initial assumption is called null hypothesis and the opposite is called alternate hypothesis. Everyone got it? Yes. Sujita and Ipsita got right. The second question. Everyone should know that what is p-value in statistics. What is p-value in statistics? Yes. What is p-value in statistics? Why we calculate p-value? What is that? You can answer in the comment window, in the chat window. Okay, I think I should write the answers as well. P-value is that p-value helps to arrive at a conclusion. When p-value is small, the null hypothesis is rejected and the alternative is accepted. When p-value is large, then null hypothesis accepted. So p-value just help us the arriving the conclusion. If p-value is small, then null hypothesis is rejected. If p-value is greater or large, then we can accept the null values. Then number three, I'm writing only hints, not the full answer. The third question, what are the different type of, yeah Sujit, you are correct, missing value treatment. What is the different type of missing value treatment? That means what is the different type of imputation, the different type of imputations. And one more thing, missing value treatment, we can do the deletion of the NA values. We can delete the NA values as well. So not only imputation, there are other things also. So what are those? Trimming is used for outlier treatment, right? Yeah, we can call it trimming as well. That deletion, we can call it trimming as well. Okay, I'm writing the answers. The first one is deletion of missing values. Then, then the second one is guess the value. We can guess also, guess the value. The another is average substitution. Substitution. Another one is regression based substitution. And the final one is multiple imputation. Okay. Yeah. Yeah, Shobjit, you're correct. Then, what is gradient descent? What is GD? Yeah, Shujit, you are correct. What is gradient descent? Descent. That we do the GD search. What? Why we do? What is gradient descent? What is the use of that? Ajay, I'm not exactly getting the point. What is gradient descent? It is just a optimization technique. It is a yes. We just optimization technique. So when building a statistical model, the objective is to reduce the value of the value of the cost function that is associated with the model. Gradient descent is an iterative optimization technique used to determine the minima of the cost function. It is used to improve the accuracy, like Sujit said, and minimize the cost function. Yes. So, what is the difference between unsupervised and supervised learning? What is the difference between unsupervised and supervised learning? What is the difference between unsupervised and supervised learning? Yeah, GD minimizes the cost function. Yeah, only Ipsita is answering for this question. And Ipsita, you are correct. Yeah, Shujit. Jasprit is also answering. So, supervised learning are the class of algorithm in which model is trained by explicitly leveling the outcome. Where the level is there, that is supervised. Example, the classification and the regression. But where there is no outcome, there is no output, there is no outcome, and the algorithm is made to learn the outcome, that is called unsupervised learning. Example, association rules, clustering, all these things. Next, why we need regularization techniques? Why we need why we need regularization technique while building a model? Yeah, Sujit, you are right. All are answering right. Yes, Sujit is right here also. So, regularization is used to penalize the model when it overfits the model. It predominantly helps in solving the overfitting problem. So, when it is a overfitting case, we do regularization. Yeah, if Sita, you are also correct. Next question. What is the difference between bias and variance trade-off? What is the difference between bias and variance trade-off? What is the difference between bias and variance trade-off? Anyone? Ishita is correct. So, high bias is underlying error, wrong assumptions that makes the model to underfit. High variance in a model means noise in the data has been too taken seriously by the model, which will result in overfitting. Typically, we would like to have a model with low bias and low variance. Yes, Ipsita, you are correct. Next question. How to solve overfitting? I'm again repeating the number 7 question. That answer is high bias in a underlying error, wrong assumptions that make the model too underfit. High variance in a model means noise in the data has been taken too seriously by the model, which will result in overfitting. So high bias is tends to underfitting and high variance tends to overfitting. Typically, we would like to have a model with low bias and low variance. So the better model is low bias and low variance. Okay. The next question, how to solve overfitting? How to solve overfitting. Yeah, using the more number of data set or a large data set, we can use that for reduce our overfitting. We can use that also. By PCA, I don't think that by PCO we can reduce our overfitting. Yes, regularization we can do that. So for overfitting, if there is overfitting, we can do regularization technique. The first is the regularization. Then we can perform cross validation. Then we can reduce the number of features, but we can increase the number of entries. We can reduce the number of features, but uh, increase the number of entries. And the last one is we can do ensemble techniques. We can use that as well. Yes, always use balanced data set. Next question, number 9. Yeah, okay, I will check that. If yes, then I can tell you. I'll check that. I'm not sure, but I'll check that. How do you detect the presence of overfitting in a model? How do you detect the presence of overfitting in a model? It's an easy question. Yes. How we can detect the presence of overfitting in a model? Yes, Sujit is correct. Sam is also correct. Ajay correct. If train accuracy is more and test accuracy is less, then we can tell that this model is overfitting. The next question. How do you determine the number of clusters in clustering? How do you determine the number of clusters in clustering? Yes, elbow curve. What the elbow curve shows. So we can determine the number of clusters by a elbow curve. Okay. The next question. Sorry guys, sorry. There is network issue. What are the different type of data? What are the different type of data? Yes, balanced data, imbalanced data. Then actually the data is divided into two parts. First is numeric data and another is categorical data. Numeric variables is further classified into discrete and continuous data. Categorical data is classified into symmetric sampling and stratified sampling. That is the different type of data, numeric and categorical. So the next question. Yeah, yeah, Sham, you're correct. structure unstructured, that is also correct. That balance imbalance, that is also correct. What is an ensemble learning? What is ensemble learning? What is an ensemble learning? Yeah, anyone? Yeah, you guys are correct. Ensemble learning is the art of combining more than one model to predict the final outcome of an experiment. Commonly used ensemble technique tagging, boosting, and stacking. Yeah, Sujat, you are correct. Sorry, guys, I was in mute. So, sorry. I was in mute. The last question's answer is the ensemble learning is the art of combining more than one model to predict the final outcome of an experiment. Commonly used ensemble techniques, bagging, boosting, and stacking. So the next question, explain normal distribution. And this is our last question, guys, because I had a power cut. So this is our last question. Okay. Normal distribution is a basic distribution that describes
Okay, friends, we'll continue our session tomorrow at same timing 4 p.m.